Hi, let's solve question 18 from the Tsokos specimen, paper 2HL. Two speakers emit sound of the same wavelength in phase. This is the two speakers. And they are emitting sound of the same wavelength and in phase, so they are called coherent sources. Okay? And whenever coherent sources are mentioned, we think of interference. Okay? Interference is a phenomenon when you got like two sources that coherent to each other, and then it can generate a pattern of bright fringes and dark fringes, and that the constructive interference and destructive interference on the screen. Okay, and then they give us a point P here, which is at distances like 12.4 meter away from the first speaker and 13.3 meter away from the second speaker. And it said that no sound is observed at P, which means that no sound means it should be a destructive interference. They ask for what is the shortest possible wavelength of the sound. Okay, so with this topic, you can have a look at the topic C3 for the SL in the IP program. Okay, and basically in order to determine what could be the wavelength, we can think of, okay, this is the hints that provided, P, no sound, and there should be destructive interference, and it depends on the path difference. If we got the path difference equals to an integer of the lambda here is the wavelength, right? Then if you got integer means that n can equal to 0. It means that there's no difference between the two paths, or it can be like 1, or it can be like 2, or it can be like 3, and so on. It can also be like -1, -2, -3, and so on, right? As long as it's an integer. So it can be either an odd integer or an even integer, or it can be even negative. Okay? So if it is positive, which just mean that here we got, this is like the P here should be on a screen, you know. Let me draw it here. This is a screen that perpendicular to the center, right? Like this is the center, the midpoint between the two sources, and then we draw a line here. That's the distance from the source to the screen here. Okay, then we can decide that everything that on top of this one above that horizontal line will be positive, and that the other direction would be negative, just like to help to determine the position of on the fringe on the screen, right? So they can be either negative or positive. This should be a negative, this should be positive. And if the path difference equals to an odd integer, okay, of half of the wavelength, then we got it like destructive. That should be dark, okay. Another way to write this one is that you can also have like 2m plus 1 times lambda over 2. So then we can just like multiply 1/2 into the terms here, you know. We can distribute 1/2 into it. Then we got like half times 2n plus 1/2 times 1, right? Together times with lambda. So then you can also have another kind of thing that should be like, this is n, and it is just like half, right? So then it can turn, so when you got n equals to 0, then you will have this one as like 1/2 of a lambda, right? Or like when n equals to 1, then you will got this one is like 3/2 of a lambda, right? Or when you got like n equals to 2, then you got is like 5/2 of a lambda. So it's always like half an integer of a lambda, or you can say that it should be like an odd integer times with half of the lambda. Okay, here if you use this form, you have to remember that should be an odd integer. Why? Because if you forget and you just take it, oh, it can be like an even integer, then you times with half of a lambda, then this one just equals to a lambda, right? And then this one just turned out to be like a whole integer times with lambda, and then this should be the case of the constructive. So it never be a even number here, you know, if you use this kind of form. Okay, just remember it's somewhere like half an integer of the lambda to be destructive. Okay, so I just highlight here, this thing can never happen. Okay, this one should be a odd integer if you use this kind of form. So here, just apply in this case. We know that at P it should be no sound and it should be like destructive because on the wave at P they will cancel with each other. So that's why we should have that the path difference here. Okay, we can calculate the path difference, right? It's just basically 13.3 meters subtracted by 12.4 meter, and then this one turns out to be, yes, that's right, 0.9 meter. Okay, so now we put that the path difference is 0.9 meter, then we can just use that equation, right, for the destructive integer, half the integer of the lambda, right? So when you got n equals to 1, then you will see this one will be like 0.9 meter equals to oh, we should start from 0, my bad. Okay, so if it's like n equal to 0, then you got like 0.9 meter equals to half of the lambda, right? So then by then you will got lambda equals to 1.8 meter, right? Okay, but they asked for the shortest one. So we can see that in order to find the shortest one, like to find a small values of lambda as possible, we will need this one to be like the greatest as possible, right? So we need to keep continue. When n equals to 1, then we will get, let me move this one below here a little bit, and we have more space. Okay, so this one will be equals to 3 half of a lambda. Then we got now just solve for lambda. Then it should be what? It should be here 2 multiplied with 0.9 and then divided by 3, right? So then it should be 0.6 meter. Okay, now continue. Let's see how low it could be. This one equals to now 5 half of a lambda, right? Then we see this one should be equals to that will be 1.8 divided by 5, right? And just using the calculator, I found to be like 0.36 meter. Okay, so this is like even lower than this one, right? So, but this one is not correct. So we got this one, and this one will result in a destructive interference, and this is the lowest one, so we go with this one. So the answer is B. Okay, and if you can see this one here, you see 0.9. So actually this is a constructive, right? That's when n equals to 1, and with this one it should means that when n equals to 2. So both at these wavelength will result in a constructive interference at P, sorry. So you can imagine like they can change the questions a little bit. They can say, okay, now at P you can hear the sound the loudest, and then you should go with this one, okay? But in this case they ask for like no sound. That should be destructive, and that should be the answer. So once again, remember this is the form, okay? Either half an integer of the lambda, or if it this one, it should be like an odd integer times with lambda divided by 2. Okay, thank you, good luck.